All right, my friends, notice that for each of these, the lower bound is always 1 and the upper bound is always infinity, just like in this rule. And then the integrand is always 1 over x to some constant power, just like in the rule. So basically, if you just follow the rule here that I know I haven't explained very well at all, but if you just follow the rule inside the bubble, then you pay attention, first of all, to which side of 1 your p-value is on. So 8 is in the greater than 1 category. And so for part A, you would just follow the rule and you say this would equal 1 over 8 minus 1, aka 1/7. There we go. For part B, same thing. Pay attention to your p-value. Which side of 1 is it on? It is on the greater than 1 side, which means this would converge to 1 over 2 minus 1, also known as 1. There we go. If your p-value is 1.1, again, that falls on the convergent side of p-values. And so this one, your answer would be 1 over 1.1 minus 1, which would be 1 over 1/10, which would end up being 10. Okay, and then for part D, your p-value is 1. And so that falls on the divergent side. And so we would say that this one diverges. There we go. And we could be more specific. We could say it diverges to infinity. But since it didn't ask, then we could just say diverges. All right, before we, call it a day here, I did want to at least demonstrate one of these and to kind of show why the rule that you see here, where the answer is 1 over p minus 1, why that actually makes sense. So, so I think I'll maybe use part A here. So let's say you did part A without the shortcut. You did 1 to infinity of, let's call that x to the negative 8 dx. And then that would be the limit as b approaches infinity of the integral from 1 to b of x to the negative 8 dx. And now watch what happens when we use the power rule here. Really, that should help you to see why the shortcut is the way it is. So when we use the power rule, you take the opposite of what was p, and we'd add 1 to it. And so we'd have x to the negative 7 in this case, divided by negative 7. Oops, I forgot the rest of my notation here. And be going from 1 to b. And then we'd have, I'm going to plug b in here, and I'm also going to fix the negative exponent. So we'd have 1 over negative 7b to the 7th minus 1 over, now plugging 1 in, we just end up with negative 7. Okay, so now let's see what happens. So as b approaches infinity, what's going to happen here to this piece? This piece would approach 0, and then you'd be left with subtracting negative 1/7, which would leave you with positive 1/7. And so, so the rule, this 1 over p minus 1, it makes sense because of the way the power rule, works and how simple it is, and that's why the rule is so simple as well. So hopefully seeing one without the shortcut next to using the shortcut kind of gives the rule a little bit more believability. All right, my friends, that is it for this lesson. Hopefully you feel like you can do all sorts of fun improper integral work. It's a nice ending to this lesson to the chapter 7, because it pulls a lot of the big ideas together all in one lesson. And we'll see all of this later in chapters 8 and 9 again. So do your best. Ask me questions for the parts that don't make sense. Take care, everybody.